All right, we're going to move into one of the special parts of similar triangles, and that's called, well, similarity between right triangles. And that's going to involve geometric mean. Now, there's a little bit of debate on how much emphasis we should put in geometric mean. And, some people are going to view it differently. But one of the values I find in the geometric mean is really for your SAT prep. This is a really quick way to solve similar right triangles. There's some deeper things to it. And I'm going to show you what some may call shortcuts. And I actually do call them shortcuts. And shortcuts are a double-edged sword in mathematics because they could take away from the deeper definitions. So use geometric mean with caution. We're dealing with similar triangles. I'm kind of interested in geometric mean with right triangles in that how it implies with Euclidean geometry and how we can turn rectangles into squares using geometric mean. And that's stuff that you could look up on your own. So let's get started because it's late. So I'm going to go ahead and create an altitude here. I'll go ahead and draw it. Let's make it blue. So here's my altitude. And what I just did was I created 3 triangles. Hopefully you see them. So I got 3 triangles. I have triangle 1, triangle 2, and the big triangle. And we can prove that they're similar pretty quick using angle. And it doesn't matter. I'll do that real quick. So let's take a look at this angle right here. And it's reflexive to 2 of these triangles. And I'm going to just pick any number. It doesn't matter what, 40, 50, whatever. I'm going to be able to prove all the rest of the angles once I know that because this is 90 degrees right here. I'm going to pick easy numbers. So I'm going to say 30. So that makes that 60. Well, if that's 60, this has to be 30 over here. And of course, this is 60. So we have angle, proving all 3 triangles similar. That means we can set up proportions with all the sides. And if we have proportions, we can solve all kinds of cool stuff. But right triangles also have a very unique feature. Now what I did was, I took this triangle, I stole it from some website, and I broke this triangle to right here. I put this triangle to right here. And this big triangle, I had to flip it and rotate it. And here it is right here. So we can set up proportions that r is to h, right here, is equal to a over b, so on, okay, etc. I can set up all kinds of proportions, but geometric mean is going to be playing with a couple of specifics. Let's go ahead and take a look at 2 of the shortcuts. And a lot of people call these theorems because they're geometric proofs, so they're theorems. And one's altitude rule and one is leg rule. So in short, it says if you have altitude on a right triangle, it splits it up into your 3 right triangles. You're going to have part of the hypotenuse. Here's my hypotenuse. Now, when we're talking about hypotenuse, we're still talking about the big triangle only. Here's part of this hypotenuse, and here's part of this hypotenuse. We can have part of the hypotenuse over the altitude is equal to the altitude over the other part of the hypotenuse. Now, this is what we mean by geometric mean. Remember means and extremes from middle school? Well, this is your mean right here. Now, that's also an arbitrary thing. It's just a convenient little tool. So these right here are the same. And that's what makes a geometric mean right here in solving our proportions. So, and then we're going to look at this rule right here, where we have the hypotenuse over the leg. Hypotenuse, this is the whole hypotenuse, okay, over a leg is equal to the leg over a projection, part of this, one of these parts, this part or this part, okay? But we're going to play with that. And again, the legs are the same. It's the same leg. So let's take a look at an example. We're going to use the altitude rule first. Basically, we're given an altitude or we're going to find an altitude or the altitude's playing some way in this game. So we're going to have part of the hypotenuse. Now remember, this is my hypotenuse right here. I'm going to have part of it. I'm going to take the 9 and go ahead and put it over the x. Hey, stop that. I have a new pad, but I was holding it wrong. So I'm going to have part of the hypotenuse over my altitude is equal to my altitude over the other part of the hypotenuse. Some people call this side altitude, side. When you go look on the websites, you're going to see some of this. And basically we're calling this side. Remember, these are my legs over here. So side and side of the hypotenuse, okay? And here's my altitude. Cross multiply, I'm going to have x squared is equal to 27. And remember, we're only taking the positive root because we can't have a negative length. So we're going to have x is equal to radical 27, which is 3 radical 3. All right, let's take a look at the next example. It's late. No altitude. So we're going to have to deal with the leg roll. Now, again, some people call this a hypotenuse, leg, leg, side. Remember, these are my legs, okay? These are my sides down here. And this whole thing is my hypotenuse. All right. So we're going to... Hey, stop it. Stop it. Stop it. Well, it just won't go away. Well, let's go ahead and set it up. So I'm just going to go ahead and do my hypotenuse, 16 over my leg, all right, is equal to my leg over the side, 12. And I'm going to cross multiply. Well, 12 times 16 is some big old number, 196 plus 24 or something like that. So more than that. It's going to, 224. All right, is equal to x squared. All right, so I'm going to take the square root of that. Well, dadgummit, I can't do that in my head. But I know that square root of 225 is 15, so this is going to be about 14.9 something. You just toss that in the calculator, all right? And that's kind of it. I'm going to go ahead and upload this. Remember, this is a critical lesson. Well, not a critical lesson in that it's a lesson on geometry. The critical part of this is that I didn't really explore geometric mean and right triangles that much. You are going to be left on your own to do that because this is not an emphasis item in the course that you are taking. It is a good thing to look at for your SATs, which you're going to take in a couple of years. Well, 2.5 years or whatever. I'll upload this and we'll start drilling you on secant, chord, and all that stuff tomorrow. All right, bye.